Alright, today we're looking at topic 1.5 for the volume of right pyramids and right cones. A volume is how much space an object occupies. This is going to be measured in cubic units. If we first of all look at the volume of prisms and the volume of cylinders, they're going to be the same size all the way from the bottom to the top. In the first picture we have a rectangular prism. In the second one we have a cylinder. That means that we can find the volume, how much it'll hold, by taking the area of its base and timesing that by the height of the prism. So in the first case, the volume of the area of the base times the height of a rectangular prism is simply going to be length times width for the base times the height. In the second case for the cylinder, the volume is going to be pi r squared times the height. When we compare that to the volume of pyramids and cones, you'll notice that pyramids and cones aren't the same from the top to the bottom. They go to a point, therefore it's going to be less volume. Pyramids and cones have a formula that's related to prisms and cylinders, in that you still take the area of the base times the height, but now you have to divide that by 3. It's only going to be a third as much. So the volume for the first one, which is a square pyramid, would be s squared times h divided by 3. And the volume of a cone would be the area of the base times the height, which is pi r squared times the height divided by 3. And again, the first one is for a square pyramid, and the second one was for the right cone. Here we have the volumes of right prisms and right pyramids. Notice that for the prism, the right prism, the volume is the base area times the height. We write it as B times H. The second one, the volume of a pyramid is going to be 1/3 times the base area times the height, and we write it as V equals BH divided by 3. The next one, we have the volume of a right rectangular prism and a right rectangular pyramid. The volume is simply going to be the area of the base times the height, or length times width times height for the rectangular prism. And the second one is going to be length times width times the height divided by 3. On a cylinder, again, it's going to be the area of the base times the height, which is pi r squared times h. And for the cone, it's going to be the area of the base times the height divided by 3, which is pi r squared h divided by 3. In example 1, we're determining the volume of a right square pyramid given its slant height. So to calculate the volume to the nearest cubic inch, we're going to have to first of all say, well, the area of the base, I can figure that out, but the height, I don't have the height of the pyramid. I'm given the slant height. So the first thing we have to do is figure out what's the actual height of it. So remember, the slant height is 6. Halfway across the base is going to be 2. So we have to figure out, using the Pythagorean theorem, a squared plus b squared is equal to c squared. Now we can say that 2 squared plus h squared is 6 squared. Subtracting 2 squared from both sides is going to give me 6 squared minus 2 squared, or h squared is going to equal 36. Minus 4, which is 32, so h will be root 32. Let's just leave it in that form. Now we can say the volume is the area of the base, which is 4 squared, times the height of root 32 divided by 3. It's easier to work with on our calculator. So the volume is going to be 30.1698, or approximately 30 cubic inches, rounded to the nearest cubic inch. In example 2, we're going to determine the volume of a right rectangular pyramid. So now we have a volume of a right rectangular pyramid that has base dimensions of 5.4 and 3.2, and it has a height of 8.1. Okay, this time we're given the height. So what we're going to say is the area of the base times the height divided by 3 for our pyramid. So the volume has got to be 5.4 times 3.2. Now that's going to be times the height, which is 8.1, all divided by 3. And simply put that in your calculator and you're going to get 139.968 divided by 3, or approximately 46.7 cubic centimeters. Here we are at example 3, determining the volume of a cone. Determine the volume of this cone to the nearest cubic inch. We have a diameter now of 12 and a height of the cone of 18 inches. Well, we're going to need the radius, so remember the diameter divided by 2 is going to be the radius, so the radius will be 6. So we can say now the volume is going to be base times height divided by 3, which is pi r squared times the height divided by 3. Next, we're going to plug our numbers in. We're going to use the value of pi from our calculator. So it's going to be, well, the radius, as we said, is half the diameter. So it's going to be pi times r squared, which is 6 squared, times the height, which is 18. All of that's going to be divided by 3. And that is going to give us a value of 678.58, or 679 cubic inches. Here we are at example 4, determining an unknown measurement. A cone has a height of 4 yards and a volume of 205 cubic yards. Determine the radius of the base of the cone to the nearest yard. Okay, this time we're given the volume, but we're asked to find one of the pieces of information that went into it, and that's the radius. Well, what we're going to do is we're going to take our equation and write it down for the cone. So we're going to say volume is pi times r squared times h divided by 3. Now we're going to plug in all the pieces of information that we know. And that is going to be, well, here's a picture. The volume is 205. That's equal to pi, which we know, times r squared divided by, or times 4 divided by 3. Now in red you're going to notice that we're going to undo this and try to figure out what r squared is, or isolate r squared. So the first thing you're going to do is get rid of the denominator by timesing both sides by 3. Now 3 times 205 is 615. On the other side, those 3's will cancel to leave me with pi r squared times 4. Now I can clean this up a little bit. I'm going to divide both sides by 4 pi. So that means on the right side, the 4 and the pi's are going to cancel. So on the right side, I'm going to get r squared. And on the left side, I'm going to get 615 divided by 4 pi. Now remember, when you're using your graphing calculators, you have to put brackets around the 4 pi, otherwise you're going to get an incorrect answer from your calculator. So when you take the square root of both sides, you're going to get r is equal to 6.9957, which rounds to approximately 7 yards. Again, make sure you use your calculator that works. This ends lesson 1.5. What I want you to do first of all is to go back and do all the check your understanding questions after each of these examples.